Alright, we're going to start with refraction today. Been talking about waves and sound. We're going to move on to light today. And we're going to start with refraction of light. Now, what is refraction of light? Now imagine that we have some body of water. Okay. If we have a light beam that shines into it at an angle, that light beam tends to bend. And we know this because we've seen pictures of, or we've even messed with, like a straw in a glass. The straw looks bent when you look at it through the water because the light bends. That's what causes the straw to look bent. That's called refraction. Now, let me draw a better picture. So this is the surface of our water. We'll use water for now. Most of your problems tend to deal with water or glass or some such type thing. So that's the surface of our water. And here's our light. Okay. So the light comes down like this. There we go. Alright. There is something that you should be familiar with from the terms you defined a while back. Something called the normal. Okay. That is the normal. A normal is perpendicular to the surface of something. So the angle between the light and the normal is called theta I, and it's the angle of incidence. It's basically the angle at which the light strikes the surface of the object. So that's the angle of incidence. Now, after the light goes through the water, make it green light now, it will have bent a little bit. Okay? And the normal is still perpendicular to the surface. I'm not doing a great job of drawing this, but I think you get the idea. Still perpendicular to the surface. So that angle here now is called theta R, and that is the angle of refraction. Okay, so just moving forward with today's lesson, you need to know that the angle of incidence is the angle from the normal at which the light strikes the surface, and it's usually something like glass or water or some other liquid, something that light travels through easily. And the angle of refraction is the angle from the normal that the light travels after the boundary. So those are your two basic ideas to start with. Okay, so remember all that. Before we go on, we need to talk about something called the index of refraction. The index of refraction. And the index of refraction is given by this formula, n equals c over v, where n is the index of refraction, okay. C is the speed of light. Speed of light is usually c. And v, and that's the speed of light in a vacuum. And v is the speed of light in whatever medium we're talking about. So the speed of light in water, the speed of light in glass, the speed of light in green jello, whatever. So that's a simple formula. Index of refraction n equals the speed of light over the speed of light in the vacuum over the speed of light in that particular substance. That's just what the index of refraction is. So we've talked about what angle of incidence was, what angle of refraction was, and what the index of refraction is. Generally this will be given to you, or you'll be given the velocity in the medium and you can find it. It's not going to be hard. It's just simple stuff. Alright, now we need to talk about Snell's law. Snell's law tells us how to find out how light refracts. So if light comes here, depending on the indices of refraction, maybe the light will do that. It tells us basically how to find the two angles. It relates the two angles of incidence and refraction to the indices of incidence and refraction. So here it is. Snell's law is Ni sine of theta I equals Nr sine of theta R. That is the index of refraction of the first medium, which is wherever the light's coming from, times sine of the angle of incidence equals the index of refraction of the second medium, whatever it's refracted by or refracted into, times sine of the angle of refraction. So you'll be given 3 of these 4 variables and it'll be easy to solve. So I'll illustrate real quickly. Let's say we wanted to solve for nr. We want to know the index of refraction of something. You just divide by sine theta r, so it would just be Ni sine theta I over sine theta r, and that'd be easy. Let's say we wanted to find theta I. Well, we divide by Ni, so we'd get sine of theta I equals Nr sine theta r over Ni. Okay, but what now? How do you get rid of a sine? Well, remember opposite of sine is sine inverse, so we do that to both sides. That cancels the sine. So we'll have theta I equals the sine inverse of that whole thing, Nr sine theta r over Ni. And that's how you would do it. This is easy stuff, basic algebra, a little bit of trig. You should all be in trig class anyway, so, or have completed it already. So this shouldn't be a big deal. Easy stuff here. We have one more thing to talk about, and that's the idea of a total internal reflection. And what the heck is that? Well, I'll write it. Total internal reflection. A total internal reflection is when you have a medium and a light source, and the light can't escape. None of it is refracted, it's all reflected. Oops, that shouldn't be an error. None of it's refracted, it's all reflected. Okay? It's called a total internal reflection. And you know that one of these is going to happen, or has happened, when the angle of incidence is more than something called a critical angle. And I'll write that. A critical angle. And you will occasionally be asked to find the critical angle, but it's really, really easy. Here's why. The critical angle is any angle, the critical angle is the angle where this happens. Here's our surface between boundaries or whatever. The critical angle is the angle of incidence for which this happens. The light comes and then it's refracted parallel to the surface. So for this theta, is our critical angle. Okay, that's the critical angle. Now remember that that's the angle, it's an angle of incidence here. Remember that angle of refraction is measured from the normal, so we would have an angle of refraction here of 90, and that's why finding the critical angle is easy, because you'll be given Ni and Nr, you'll know theta r, because if it's a critical angle, then the angle of refraction has to be 90 degrees, so you'll just be looking for theta I, and that's how you find a critical angle. So it would look like this: Ni sine theta I equals Nr sine 90, but what's the sine of 90? Equals 1, so really we're just going to have Ni sine theta I equals Nr, which means we could really write a general case formula here if you want to write this down. The angle of incidence, which in this case, critical angle, would be be the sine inverse of Nr over Ni. That would get you the critical angle every single time, if you knew those two things, if you knew the two indices. So, there you go. That's basically it.